Welcome to the second video for Tech 240 on Wednesday, April 14th. In this video, I'm going to try to help you out on labs 17, 18, and 19 by giving you a tutorial on the software that we're going to use for those labs. You might remember in the first third of this class, we used Tinkercad software to do some of those labs. And for this last third of the class, we're going to switch and we're going to use a program called MultiSim Live. Why are we switching from Tinkercad to MultiSim Live? Well, there's a couple of reasons. The first and possibly most important reason for switching is that Tinkercad probably couldn't handle doing these labs. It would either be very slow and frustrating, or in some cases, it just wouldn't work. I've tried to do these labs in Tinkercad, and it's either very slow or it just refuses to play. It just is not capable of doing some of this analysis. So that's the first reason. The second reason why we're going to switch to MultiSim Live is because it's actually good experience for you because it's a professional level tool. It's free, but it's legitimately professional quality software. And so I would actually suggest that after completing this section of the class, you could actually put competence in MultiSim Live on your resume. It is a widely used software tool that is used in the electrical industry, as opposed to Tinkercad, which is not. Probably a good analogy to use is that Tinkercad is kind of like the Google SketchUp of electrical circuits software. So, people that really know CAD software, they kind of look down their nose and laugh at Google SketchUp, right? In the same way, people working in the electrical industry definitely would look down their nose and kind of snicker at Tinkercad electrical software analysis. In comparison, MultiSim Live is legitimately a software program that is used in the electrical industry. So people in the electrical industry would not look down their nose and laugh if you explained that you were competent in using MultiSim Live. It's still pretty intuitive to use. I found it to be pretty easy to learn as I've learned it over the past couple of years, and I think you will as well. One thing that you'll notice is that in Tinkercad, part of what made Tinkercad so intuitive was that they didn't really use electrical schematic symbols. When you were in Tinkercad and you pulled out a power supply, it looked like a power supply. And when you pulled out an LED to connect in your circuit, it looked like an LED. So when you're finished with your diagram, it's not really an electrical schematic diagram. It's just kind of a picture of what you would have on your desktop if you were actually assembling these components. So that makes Tinkercad pretty intuitive, but it also makes it not very professional because it's not using electrical schematic symbols. In comparison, MultiSim Live does use the correct electrical schematic symbols. So you'll see that. You'll see the symbols for voltage supplies, and you'll see the symbols for capacitors and resistors and things like that. Even resistors, remember in Tinkercad, they didn't use the little symbol for resistor. They used something that actually looked like a resistor. So you'll notice that in MultiSim Live. It might make it slightly less intuitive, but it's a lot more professional quality. So that's good for you at this point. It's good for you to get exposure to using professional quality software, even if we're not going to utilize anywhere close to all of its capabilities. It's good for you to learn how to use it. MultiSim Live is made by a company called National Instruments, otherwise known as NI, and they are based in Texas. But they're a big worldwide company that makes very reputable testing and analysis software and hardware. They make a lot of really high quality instrumentation and lab instruments and things like that. So they're a very well-known company, just like their software, MultiSim Live, is a well-known company. Software product. So to get started, I'm going to share my screen in just a minute, but I'm going to tell you where to find this software. As I mentioned, it's free. It's also web-based, so you don't have to download anything, just like you didn't have to download anything for Tinkercad. So that is another thing that I like about MultiSim Live. It's free, you don't have to download anything. To find it, you can either type into your Google search bar MultiSim Live, and that's MultiSim space live. Or you can just go directly to the website. It's www.multisim.com. Once again, that's MultiSim.com. So I'm going to share my screen at this point, and I'll walk you through some of the steps that you're going to use when you're completing labs 17, 18, and 19. All right, when you go to multisim.com, this is probably the page you're going to land on. Probably none of you have an NI account. I do already, so I'm going to click log in. But when you come here, you're probably going to have to click sign up. It's free. It's really easy to register. It's like registering with Tinkercad. It was super easy to do. So I'm going to go ahead and click log in, like you can do once you have an account. And then you need to log in to your NI account. And then once you have created a couple of circuits, it will show you your latest circuit, but you don't have any circuits yet. So click Create Circuit up here in the upper right corner, and it's going to open a new file for you. And what we're going to see is a blank screen where we can start creating electrical circuits right here. All of your symbols that you're going to use for your components are over here on the left side of the screen. We're going to use comparatively very few of these. We're only using a fraction of MultiSim's capabilities. But we're going to use some voltage probes in a little bit. We'll use this one. This is like a multimeter. This is a probe to measure voltage. Here is the ground. We'll use that one in a little bit. Here are some power supplies. The one that we're going to use is an AC voltage supply right here. We'll use that in the next few labs. Here are a bunch of different components. The ones that we're going to use in the next few labs are resistors and capacitors and inductors. So we'll use these three. We're not going to use any of these amplifiers right here. Diodes, we will use just this basic diode right here on the left. We're not going to use any transistors or indicators or switches, and none of these logic or relay circuits down here. But there are lots of different things that MultiSim can do. We're just kind of scratching the surface, but you'll get some experience doing this. So what I think I'll do for demonstration purposes is I will build an RC low-pass filter. It won't be identical to the one you'll do in the next lab, but I'll go ahead and show you basically what we're going to do. So I'm going to go ahead and pull out a voltage source, and I'm going to duplicate this by clicking on this right here. It's just a way to quickly duplicate it. So now I have two voltage sources. This will work. And I'm going to make one of these voltage sources a relatively low frequency and one a relatively high frequency. And then that will serve as my input to my filter. And I'm going to try to filter out the higher frequency and just be left with the lower frequency, because this is a low pass filter, right? So I think for right now, you're going to change these parameters. You can click on these to change them. So I'm going to set both voltages to 20 volts. They're both going to be 20 volt sources. And I'm going to put one of them, I'll make this one a low frequency. I'll say this is only 30 hertz. And the other one is, we'll say 500 hertz. All right, so now I have two AC voltage sources. They're both at 20 volts. That's the amplitude of the waveform. And the frequency of this one is only 30 hertz, while the frequency of this one is 500 hertz. So I'm going to wire them in series, and these are going to add together. These waveforms are going to add together and give me kind of a funky looking, kind of noisy waveform that I'm going to try to filter. So that's going to be my input after I wire it together. I'm going to go ahead and put my other components in. So I need a resistor, put that up here. And I also need a capacitor. And it comes out horizontal, so you can just rotate it with this button right here. So now we rotate it, and then we can move it around. I'm going to put it right there. And now I can wire things up. So I'm going to wire. And by the way, you don't have to click on anything to get the wire. Just move your cursor to the end connection of a component, and it turns into a wiring. It looks like a piece of solder. That's what it looks like. It looks like solder, but you're just wiring this up. So I'm going to click here, and then click up here to make the connection, and then click here to down here, and then click here. And I can click, if I want the wire to come down here, I can click down there. I'm going to click there so it comes through there and then up like that. And that's the last thing right there. Now it's all connected. We do need a ground in order for the analysis to work correctly in MultiSim, for the simulation to work right. You do need a ground connection. And we can put it anywhere down here, really. Anywhere will work. I'm going to put it right there. All right, so that is our circuit. Looking good so far. And now what I want to do is I want to run this simulation. So what we need to do that, I want to be able to see the waveform. I want to see the plot. So we're going to click on split up here so that half of our screen is the schematic and half of our screen is going to be the graph. So we'll see the plot of the waveform. The other thing you want to make sure of is that up here in the left corner, you're in interactive mode. There's a couple different modes, but the one that we're always going to use is interactive mode. So make sure you're in interactive mode. And after that, we are all set to run this simulation. So to do that, I'm going to click the play button. And then it's going to count right here. It's going to count up in simulation time. Simulation time is not necessarily the same as your wristwatch time. It's not the same as elapsed time for you. So you need to watch up here. It depends on how fast your computer is and how fast the MultiSim application is working at that point in time. For our purposes, you want to let it run for a few seconds. You really don't need any more than that. So I'm going to click run. And here it goes. So it starts out in milliseconds. Now it's up to 1 second, 2 seconds, 3 seconds. So that's plenty. That's fine for us. And I see that I made a mistake because I forgot to do something, but that's fine. When I do these examples, it's not a problem when I make a mistake because it provides me an opportunity to tell you what not to do. So it wasn't really a mistake, but I did forget something here because I want to plot the data, but I didn't connect any probes, so I'm not going to get any data. So that was silly, but no problem. I'm going to go over here and connect a probe. So I forgot to do this, but you want to make sure you do this. If you forget, it's no big deal. You just won't get any data like I did. So attach a voltage probe, and I'm going to use 2 voltage probes. I'm going to use one right here. This is the input to my filter. That's my signal input. And I'm going to use another one, and I'm going to put it right here. This is the output, right? Because the output is taken across this capacitor. And these probes, both of them, by default, are going to measure the voltage in reference to ground. Remember, voltage is an across variable, so you're always measuring voltage in reference to something else. And by default, they will use ground as their reference 0 voltage. All right, so now we should be all set to run this. And when I do, we're going to see 2 waveforms. One is going to be green, and that's going to be from this probe. That's the input to my filter. And the other waveform should be blue. That's going to be the output to my filter. So let's go ahead, and we should be able to run this now. It's going to count up. 1 second, 2 seconds, 3 seconds, and that's plenty. All right, that's plenty. All right, so now you can see kind of the waveforms over here, but it's a mess. I don't know what this is telling me right here. You can scroll on your wheel and you can kind of change the values of the axes. But there's an easier way to do that. So to do this and make it more easy to see what's going on, click on this gear button up here for settings, and then scroll down to the bottom and you can control the axes. So I'm going to change the horizontal axis, which is time. I want to start at 0 seconds and probably a tenth of a second, 0.1. That should be fine. That should show us what we want to see. And then for the voltage, that's the vertical axis. I've got two 20-volt sources. So if they're both added together, then I could get as high as 40 volts. So let's go with a maximum of 45. Oh, it's minimum first. Minimum of negative 45 volts and a maximum of 45 volts. Okay. That looks about like what I would expect. So notice I didn't do anything with changing my resistor or my capacitor yet. So I really haven't adjusted or tuned the anything about the cutoff frequency of this circuit. So as it turns out, let's go ahead and do this calculation. What is the cutoff frequency for this circuit? We can go ahead and do that. We know that we had a resistance of 1,000 ohms and we had a capacitance of 1 microfarad, which is 1 times 10 to the minus 6 1 times 10 to the minus 6 farads. So let's go ahead and do the cutoff frequency. The cutoff frequency for an RC filter is 1 divided by 2 pi RC. So I'm going to take my calculator. I'm going to do 1 divided by parentheses 2 times pi times R is 1,000 times C is 1 times 10 to the minus 6, which is 1e minus 6, 1e negative 6, 1e to the negative 6, into the parentheses, and we get a cutoff frequency here of 160, about 160 hertz. So the cutoff frequency is kind of somewhere in between 30 hertz and 500 hertz. It's in between there. And what we can see with the waveform, we see the green waveform, which is the input, and we can see that we can clearly see these two different frequencies, right? You see the low frequency that's going up and down and up and down and up and down like that. That's the low frequency. But you also see that added to the higher frequency, and that's going up, down, up, down, up, down, up, down like that, much faster, right? So you can very clearly see here in the green curve that this is the combination of two different frequencies, a low frequency and a high frequency. In the real world, in real life, it won't just be the summation of two frequencies. It'll be a lot of different frequencies that you're trying to filter out. All right, but for simplicity's sake right now, we've just got two voltage sources. So our blue curve is what we're trying to get. That's our output. And this is an RC low-pass filter. So what we're trying to eliminate is this really fast up and down, up, down, up, down, up, down, up, down, up, down. And all I really want is this slower oscillation up and down like that. All right, so I want this frequency in my output, but I don't want this faster frequency, up, down, up, down, up, down, up, down, up, down, like that, all right? So I just created an RC circuit. I didn't even change these values when I dragged them out, but in your lab, you're going to change these values to design different kinds of RC circuits. And just for fun here, let's play around with this a little bit and change these values, thus changing the cutoff frequency, and see what happens to our output. So take a mental snapshot of what this plot looks like over here, all right? So you can clearly see the lower frequency, but there's quite a lot of high frequency component remaining in this output. So what I'm gonna do is change the value of this capacitor. I'm gonna double it. So it was 1 microfarad. I'm gonna make it 2 microfarads. And now I need to run the simulation again. So I'm going to click run, let it go for 1 or 2 seconds of simulation time. That's good. And then I'm going to adjust the parameters on my graph again so I can see what's going on. So if I hit enter, yeah, if I hit 0 here, it'll automatically go back to what I last told it to do. So I think you can see a difference here. I can. Hopefully you can see a difference. We've still got the low frequency in our blue output curve, but we have considerably less of the high frequency. So if there's still some, it's going up and down, up and down, up and down, up and down. But the blue curve is definitely smoother than it was previously when I had the 1 microfarad capacitor there. Let's keep going. Oh, you know what? First, let's do the cutoff frequency of this. So all I have to do is the same thing. 1 divided by parentheses 2 times pi times 1000, that's the resistance, times 2e negative 6, because I have a 2 microfarad. So now, it's probably not surprising since I doubled the capacitance, I have half of the cutoff frequency. So now my cutoff frequency, instead of being 160 hertz, now it's 80 hertz. 80 hertz is the cutoff frequency. So it's worth noting that just because your frequency is above the cutoff frequency doesn't mean it's going to block it. You see what I was meaning before where I said it attenuates it, not blocks it? Because even though 500 hertz is well above the cutoff frequency, we have not completely eliminated that high frequency from our output. We've only attenuated or minimized the high frequency from the output. All right, but it's still there. It's just much lower in magnitude. Let's keep going. I'm going to double it again. I'm going to go up to 4 microfarads. See what this output curve looks like. So again, the green is not going to change. The green is the input, so I'm not changing anything about that. All I'm changing is the cutoff frequency of the filter, and so my output curve, my blue curve, is going to be changing as I change the capacitance of this capacitor. So let's go ahead and run this one. There's 1 second. There's 2 seconds. That's good. Now let's go down here. If I just hit 0, yeah, okay, it takes me back to what settings I had before. And again, I would say it's a little bit smoother than what it was before, a little bit. And now we could plug this in again to our calculator. What's the cutoff frequency now? 1 divided by 2 pi times 1000 times 4 e negative 6, 4 times 10 to the minus 6. And it's going to be half again what it was. So now I got about 40 hertz. That's my cutoff frequency. Let's do it again. Let's see what, you know what, maybe I'll just go, now I'll double it again. We'll go at 8, and we'll run it again. Okay, what's that output curve going to look like? It's getting smoother, isn't it? It's getting smoother, and we are reducing the high frequency components in this output curve. Let's do it one more time. Let's go up to 16 microfarads. Okay, and then let's change the plot parameters. There we go. All right, so we have definitely made it quite a bit smoother, right? Our input to our filter was this green curve that had low frequency components as well as these high rapidly oscillating components, high frequency oscillating components. And our output here is the blue curve that is a lot smoother than the green curve and a lot smoother than what it was initially with the 1 microfarad capacitor, right? So let's do the cutoff frequency with this 16 microfarad capacitor. 1 divided by 2 pi times 1000 times 16, whoops, 16 e minus 6, and I get about 10 hertz. 10 hertz is my cutoff frequency now. So now this actually this is a good thing to show. 10 hertz is below the frequency of even my low frequency input, right? It's below the frequency of even this voltage source. So once again, this is a good point to make, that just because a frequency is above the cutoff frequency doesn't mean it's going to block it. It doesn't block it, it just attenuates it. All right, and you can actually see that. Look at the amplitude of this curve. The low frequency input voltage was 20 volts, so it was up here. So I've really attenuated even my low frequency source right here. I've attenuated it because now the peak voltage here is less than 10 volts. It's 9 point something right here. So I've even attenuated the low frequency voltage source, but I've attenuated the high frequency voltage source even more, because I can see that there are still some high frequency oscillations in here, but overall this blue curve is pretty smooth and a lot smoother than it was initially. Make sure you follow the directions in the lab instructions. One of the last things it's going to have you do is change the file name. So for example, I think it has you do last name, in this case RC low pass filter. So I'm going to type Alderman RC low pass filter. So that changes the file name. And now what you can do is take a screenshot. You can do it the same way you did it for the Tinkercad labs. I use the snipping tool. Just type in snip and your computer should come up with a way to snip screenshots. So that's what I would use. When you do a screenshot, just make sure you get your file name here, and make sure you get your schematic diagram over here, and make sure you get your graph over here. That's what I want to see. I want to see all three of those things when you submit your lab. All right, so that's basically in a nutshell how to create an RC low pass filter in MultiSim, and how to graph the output and see what the output is. I think that should be helpful to you as you're completing labs 17, 18, and 19. The instructions are also contained in pretty step-by-step detail in the lab manual itself. So lab 17 starts on page 129. And actually, I'm going to give you some more good news. I think you'll appreciate this. So lab 17 starts on page 129, and then the first couple of pages are on RC low pass filters, and then the last couple of pages are on RL low pass filters. But here's what I'm going to tell you. I think this will save you some time and you'll appreciate this. I only need you to do the section of lab 17 on RC low pass filters. So that means from page 129 through and including page 132, 129 to 132. Those are the sections of lab 17 that I want you to do. So you don't have to do pages 133 and 134 in lab 17. We still covered and talked about RL low pass filters. So you could still see that material on the next exam. You won't see it on the next quiz because, like I said, the next quiz does not cover filters. But on the last exam, you definitely could see material on RC low pass filters and or RL low pass filters. But I think the analysis is simple enough that if you understand RC low pass filters, you should be able to do the same type of analysis on RL low pass filters without having to do this extra couple of pages in lab 17. All right, so good news there. You only have to do the first several pages in lab 17. I'll do the exact same thing for lab 18 on high pass filters. I'm only going to make you do the sections on RC high pass filters, and I won't make you do the sections on RL high pass filters. Same caveats and same reasoning and everything like that. But I'll cover that when we talk about high pass filters next time. All right, so that's all the material for today. That's our discussion of low pass filters. If you have any questions, feel free to contact me, send me an email, or come to my office hours. And that's going to be it for today. So have a great weekend, and I'll see you next time.